Okay, so now we are. Do you have any doubt in aldol reaction?
No, sir.
So basically, in this aldol reaction, you have seen that there must be an alpha hydrogen, and you are going to take first mole and then another mole. First mole will be converted into nucleophile, and another mole of this will be converted into electrophile. And and then this nucleophile will attack on this electrophile, and then you are going to do hydrolysis, and then removal of H2O will take place. That will be your basically condensation part, right? Today we are going to have cross aldol, and it's very easy cross aldol. So let's start this cross aldol. Cross aldol reaction. You know what is cross aldol reaction? Basically, when you are going to react different aldehydes, just take CH3CHO, and you are going to react this with CH3CH2CHO. You know how many products there will be? There will be basically 4 products. How it is going to be 4 products in the presence of dilute alkali, that is NaOH or KOH? How there will be 4 products. First, you are going to do the aldol condensation with this alone, and you will get the same product as the first one. How it is possible? You can see separately. I'm going to do it. I'm going to do for this. This is your CH3CHO, and it is going to react with dilute alkali. And as you know that this CHO is the main functional group. This CHO is the main functional group. So what you need to do, it's very simple. Wait a minute. Pause. So this is your alpha hydrogen, which is acidic. It will, the electron of alpha hydrogen will be taken by carbon. Now it becomes CH minus, and then CHO will be there. Then again, you are going to take another mole of this CH3, C double bond OH. Now this is going to electrophile. Oxygen will take electron from carbon. Since oxygen is taking a carbon's electron, this carbon's electron, there will be deficiency of electron on this carbon. So this will attack on this carbon. So I'm going to write this part first. As you can see, there was CH3 as it is. Then there is CH. So I'm going to write it CH as this, and there was O negative because oxygen took electron from carbon. Now I'm going to write this part, since this CH2 attacked on this CH, so there will be CH2, and after CH2 there was CHO. So I'm going to write this CH. Okay. And then again there will be hydrolysis like H plus and OH minus. So this H plus will be attacking on the negative part, and you will get CH3 and then CH, and then there will be OH and then CH2CH. This is your aldol reaction. And if you are going to do this, removal of water will take place. Removal of water you will take place. Now see, this is your main functional group. So this will be your alpha carbon, this will be your beta carbon. So what you need to do is remove OH from beta and remove hydrogen from alpha. That means hydrogen from here and OH from here, and there will be double bond between carbon and this carbon and this carbon. So it will be CHO. Now it becomes CH, double bond CH, and this is your CH2. So this is your first product in the cross aldol. In the same way, you can go for propanol. Can you do the aldol condensation of propanol? CH3, CH2, CHO. Nafisa, can you do this? I think you do this. You can do this because in the previous class we did for the same. So first you are going to do for this, and then I will explain the main other 2 products. All other main products. Fawaz, why were you absent? I think Oh, you had exams. Okay. Please do write it, and Nafisa, let me know if you have any doubt in this. Nafisa and Fawaz, both of you. Let me know when you're done with this.
Yes, sir. Done.
Hmm. What is the product? Name of the product? Can you give me the name of this product after aldol condenses?
Sir, like the final one? Or,
Yeah, yeah, the
yeah,
final one
okay.
in which double bond is present.
Wait, sir.
See, by the way, I'm going to explain this. Forward C. This is your main functional group. Forward. This is your main functional group. So this will be your alpha carbon. This will be your alpha carbon. This will be your alpha carbon. So this will be your alpha hydrogen. Two alpha hydrogen is there. So hydrogen's electron will be taken by carbon. So there will be CH3, and now there will be CH negative and CH. Now again we are going to take this another mole of this as CH3, and then CH2, and then CHO, that is C double bond OH. Now see what will happen. Oxygen will take electron from carbon in the second step. So there will be negative charge on oxygen, and there will be deficiency of electron on this carbon. So it will attack on this carbon. Now I'm going to write this part first. As you can see, there is CH3, and then there is CH2, and then there is CH, and then there is O negative. Now since this part attacked on this, so there will be CH, and after CH, there on the right hand side there is CHO, and on the left hand side, which I'm going to write in the bottom as CH3. Is this clear? Fawaz and Nafisa.
Yes, sir, yes.
Very good. Now, as you can see, I'm going to do the hydrolysis of this. That means H2. That means basically H plus and OH minus. So as you can see, this H plus will be attacking on this oxygen. So there will be CH3 and then CH2, and then CH, and then OH will be there. And then again CH was there, and then CH3 is there, and then CH. After this, you are going to do the condensation part. Condensation, that means you are going to remove H2. How you are going to remove H2? OH from beta carbon and H from alpha carbon. So there will be double bond now between this and this. So all the part will be as it is, CH3, CH2, and there was CH and then double bond C, and there was CH3 on the bottom, and then comes CH. This is the second product. This is the first product, and now this is your second product. Is that clear? Fawaz and Nafisa,
Yes, sir.
please do write it first. This is the product that you got or something else?
No, sir. I got something else. I got pep.
Wrong.
Yeah, I got like
Okay.
yeah, it was wrong.
Please do write it. This is the second product. We need to prepare two more products. Okay, okay. Fawaz, I'm going to scroll off for you. Is it enough? Or should I scroll up a little bit more? Okay. Please do let me know when you are done with this. Very good. Please do let me know when you are done with this. Nafisa, are you done with this?
Yes, sir. Yeah.
Fawaz, now see, we are going to do for the third product. That is, first I'm going to take this methanol. No, sorry, ethanol was there. So I'm going to take this ethanol, and in the first case, I'm going to make ethanol as nucleophile. That means hydrogen's electron will be gained by this, and it will be CH2 negative, and then there is CH. And after this, in the second step, since two reactant were there, propanol was another. So I'm going to make it electrophile. So this is your propanol, and I'm going to make it electrophile. How it is possible? Oxygen will take electron from carbon. So as you can see, there will be deficiency on this carbon. So this carbon will attack on this to satisfy this. So I'm going to write this part first as CH3, and then there was CH2, and then there is CH. Then there is CH. Wait a minute. Can everyone see the screen?
Yes, sir.
So this is your CH2, and after this is CH, and this is O negative. And since this carbon attacked on this CH, so it will be CH2 now, and then CH. After this, you are going to do the same step, and this H plus will be attacking on this O negative, and you can see this will be your CH3, CH2. After that CH, and then OH, and then CH2, and then CHO. And then you are going to do the condensation, that means removal of water, and then OH from here and hydrogen from, since this is your alpha, basically main functional group, so this will be our alpha carbon and this will be your beta carbon. So always remove alpha hydrogen and beta OH. So what you will get, CH3, CH2, and you are going to remove this OH, so there will be double bond, and you are going to remove hydrogen from here, so it will be one H left here. So this will be your third product. In the fourth part, what you are going to do, make this propanol nucleophile and this ethanol as electrophile, then do the reaction. Please do it. Come with. Please do let me know when you are done with this.
Yes, sir, done.
Done, everyone? Fawaz, now what you are going to do, take it propanol first. Can you do this? Nafisa and Fawaz. Nafisa, can you do this? You are not audible.
I'll try, sir.
Please give it a try. Just take ethanol here, and in the second mole, you are going to take this is your propanol. For the second, you are going to take ethanol. Just give it a try and let me know.
Okay. Sir, the product will be CH3, CH2, double bond CH,
Wait
and
a minute.
then
Just
CH.
match this. No, wait a minute. Alpha hydrogen is here, so it will be released in the form of H plus. So there will be negative charge here, and then CH. Now you are going to take another mole of this ethanol that is like this. So in this way, you are going to remove this. Oxygen will take electron from carbon, and this will attack on this carbon because there will be deficiency of electron on this carbon. So as you can see, I'm going to write this part first. So there will be CH3 and then there is CH and then you can see O negative. Also, this CH is attacking on this CH. So there will be CH and after this on the right hand side, there is CHO. And on the left hand side, you can see this is CH3. So I'm going to write CH3 bottom on the bottom. And there will be H plus OH again. So in case of H plus OH, you know that this H plus will be attacking on oxygen. You will get CH3CH and then there will be OH and then there will be CH and then CH3 and then there will be CHO. After this, you are going to remove H2O. You are going to eliminate H2O, condensation will take place. OH from here, you can see this is your main functional group. So alpha carbon is here. So this hydrogen and this OH will be removed. And now there will be double bond between this carbon and this carbon. So the rest part will be as it is CH3 and after the CH double bond C because this OH and H is removed. And on this CHC there was CH3 and then CHO is. So this is the fourth product. Whenever you are going to do the aldol condensation, sorry, cross aldol condensation, you will get four products. Is that clear, Nafisa?
Yes, it was almost correct if I didn't write CH3 and then CH2.
Yeah. Oh, you didn't correctly remove.
No,
eliminate the water.
I wrote like an extra CH2 before the double bond.
Oh, that's wrong.
Yeah.
No problem. Just do some practice, you will get it. Okay.
Okay, sir. Yeah.
So please do write it and let me know when you are done with this.
Yes, sir. Done.
Fawaz, are you done with this? Okay. Now we are going to see other reactions, other Cannizzaro reactions. Wait, please. Wait a minute. I'm waiting. Wait a minute. Please do let me know when you are done with this for us. I'm waiting. Thank you. Now see, we are going to do other reactions. And in other reactions, we have the first, that is Cannizzaro reaction. That is Cannizzaro reaction. So as you can see in aldol condensation or aldol reaction, there must be an alpha hydrogen, but this Cannizzaro reaction only occurs when there is no alpha hydrogen. So I'm going to write a point with write with me, aldehydes which do not have an alpha hydrogen, which do not have an alpha hydrogen atom undergo self-oxidation, and reduction. Self-oxidation and reduction, that means disproportionation reaction. I'll explain these terms. Disproportionation reaction on heating with concentrated alcohol, on heating with concentrated alkali. In this reaction, one molecule of the aldehyde is reduced to alcohol. While other molecule is oxidized to carboxylic acid. So it's very easy. Carboxylic acid. So first write it and then let me know.
Yes, sir. Done.
Very good. Fawaz, are you done with this? Fawaz. Oh, please do let me know when you're done with this. Done. Very good. Now see what happens here. If there, can you tell me whether this aldehyde has alpha hydrogen or not? Can you recognize whether this aldehyde has alpha hydrogen or not? Both of you, please do let me know how you are going to calculate alpha hydrogen. Before calculating alpha hydrogen, there must be an alpha carbon. And you can see this is your main functional group. So the carbon which is directly connected to the main functional group is your alpha carbon. So what is alpha hydrogen? So the hydrogen which is connected to alpha carbon is known as alpha hydrogen. So there will be no Cannizzaro reaction in this because there is alpha hydrogen. Alpha hydrogen takes place in the aldehydes where there is no alpha hydrogen. Cannizzaro reaction will take place where there is no alpha hydrogen. Is that clear, Nafisa?
Yes, sir. Yeah.
So can you tell me whether this has alpha hydrogen or not? Can you tell me whether this has alpha hydrogen or not? You're going to react this with concentrated KOH and heat. Can you tell me whether this is an aldehyde or not? Is this aldehyde?
Sir, it doesn't have. It has alpha hydrogen.
No, it doesn't have alpha hydrogen. Why?
But it's connected.
This is your main functional group, right? This is your main functional group, CHO.
Yes, sir.
Is there any carbon that is directly connected to this carbon? No carbon? No alpha carbon? No. If no alpha carbon, that means no alpha hydrogen. Are you getting my point?
Okay. Yes, sir.
And it is not necessary that if there is alpha carbon, there must be an alpha hydrogen. That is may or may not be. That depends upon the structure. And there is also no alpha hydrogen. Actually, in the previous aldol, we take 2 moles in the same way. In Cannizzaro reaction, we also take 2 moles. Now, one of the aldehyde will be reduced to alcohol. Can you tell me a name of an alcohol which has 1 carbon? Can you tell me? Methanol. Please explain this again, why there is no alpha. Fawaz, this is in Cannizzaro reaction. Cannizzaro reaction will take place in the aldehyde when there is no alpha hydrogen. Aldol condensation will take only, aldol reaction will take place only if there is an alpha hydrogen. This is the condition of the reaction. Okay, Nafisa, can you tell me the name of
Yes.
an alcohol which is having one carbon? Methanol. Yes or no? You
Methanol.
have
Yeah.
studied this in the alcohol chapter. If aldehyde is reduced, it will be converted into alcohol. So as you can see, one bond I broke. So now it will be C. Two hydrogen was already there. Now this hydrogen, it becomes CH3, and now you can see this methanol. And another, this will be oxidized into carboxylic acid salt. So you are going to make it CH3, wait a minute. You are going to make a carboxylic acid of methanoic acid. Methanoic acid it is, but you are not going to make it carboxylic acid. You are going to prepare it carboxylic acid salt. So whatever is the metal here, you are going to replace that hydrogen with this K. Is that clear? It's very easy. One of the aldehyde will be reduced to alcohol, and we know how we do reduction of aldehyde. And one of the aldehyde will be oxidized to carboxylic acid salt. If there is an carboxylic acid like this, and you are going to reduce it to carboxylic acid salt, so it will be O double OK. Is that clear? Just remove this H with K or Na. Please do write it. Are you done with this, Nafisa?
Yes, sir.
Very good. Now I'm going to change the slide, and I'm going to give you a question. First, you need to check it whether there is an alpha hydrogen or not. If there is an alpha hydrogen, then the reaction will not take place. This is your CHO. So I'm going to write it CHO as this. And you are going to react this with concentrated NaOH or KOH you can take and heat. You are going to take 2 mole of this oil in the same way that you did for aldo. It's very easy. Wait a minute. Let me know when you are able to see this screen. Is my screen visible to you? क्या हो गया? Can you do this, Nafisa?
No, sir.
Okay, it's very easy, Nafisa. It's very easy. So this is the main functional group. Can you tell me? This is the main functional group, yes or no?
Yes, sir. Yeah.
So this carbon is basically your alpha carbon, right? Is there any hydrogen present with this carbon? Is there any hydrogen? Yes or no?
No.
Because it is already making 4 bonds with this carbon
Yes,
and
sir.
2 bonds with this carbon and 1 bond with this carbon. There is no alpha hydrogen, zero alpha hydrogen. That means this compound will show Cannizzaro reaction. Now see, I'm going to take the first mole. I'm going to take the first mole as it is, there is, and going to reduce it. How you did reduction in alcohols, phenols? Just break 1 bond, add hydrogen to this oxygen and 1 hydrogen to this carbon. Now you will get it. Now, as you can see, this is your benzene, and this C and hydrogen is already there, and this hydrogen will combine to form CH2. And one of the bond broke between oxygen and carbon, so single bond left, and with O there is hydrogen H. So one of the aldehyde will be converted into alcohol. Is that clear? Yes or no?
Yes, sir.
Now see another, since we have 2 mole of this aldehyde. So as you can see, this aldehyde will be converted. This aldehyde will be converted into carboxylic acid salt. That means basically this C double bond O will be as it is, and there will be introduction or addition of oxygen here, and this hydrogen will be removed or replaced by this metal. Now it is carboxylic acid salt. Is that clear? If you are going to remove that hydrogen from OH, then this will be carboxylic acid salt. It's so simple. And since oxidation and reduction of same group or molecule or compound takes place simultaneously, simultaneously, this type of redox reaction is known as disproportionation reaction. That's why I used disproportionation term in a square bracket. Bracket basically, not a square bracket. Is that clear? So please do write it. It's very simple. Please do let me know when you are done with this. Are you done with this?
Yes, sir. Done.
Now other reactions. In the other reaction, we have another reaction, that is electrophilic substitution. reaction. Electrophilic substitution reaction. So I'm going to write a point right with me. Aromatic aldehydes and ketones, whether it is aldehyde or ketones, we are talking about aromatic, undergo electrophilic, right with me. So aromatic aldehyde and ketones undergo electrophilic substitution at the ring, in which the carbonyl group act as deactivating or meta directing group. That means, can you do the, I'm going to do it. You can see this is your benzene, and for aldehyde, aldehyde is ring deactivating. That means it acts as minus R. It will withdraw electron from the ring. So what it will do, it will take carbon's electron. So this will be moving to this side. So as you can see, there will be negative charge on oxygen and there will be hydrogen. And since this electron moves to this side, there will be positive charge on ortho. Then again, you are going to move this and there will be again double bond and then positive charge to move to this. And double bond was there as it is. And then there is O negative and H. And then again, there was double bond. You are going to move this to this side and there will be positive charge and double bond moves to this side. And then this moves to this side and this moves to this side. So can you see what is the position of this positive charge? Oh, wait a minute. What is the position of this positive charge? This will move here, here, and this again as it is. So if you are good, if any electrophile wants to attack on this ring, this electrophile will not be able to attack on ortho, para, and ortho. Only there is two place left, that is meta. Both are basically meta position where electrophile can attack, because electrophile means it has electron, it will have electron deficit. It is basically electron deficient molecule. And if it is going to attack on ortho, para, or ortho position, that has already electron, that is already electron deficient. So they cannot satisfy each other. That's why in this it will attack on meta, and it is that's why this CHO aldehyde group acts as deactivating and meta directing group, because electrophile now will attack only on meta. There will be no attack on para or ortho, because para and ortho has already electron deficient. Got it? Fawaz, Nafisa,
Yes, sir.
please do write it and then let me know.
Yes, sir. Finish.
Are you done with this, Nafisa and Fawaz?
Yes, sir.
No. Now let's start your carboxylic acid. Carboxylic acid. So first of all, we are going to do the nomenclature part. So its IUPAC name is like IUPAC name is alkane plus oic acid, alkanoic acid. So if I'm going to give you a very easy, first identify the uh, functional group and then write the IUPAC name of the folder. Can you do this, Nafisa and Fawaz?
Yes, sir. We'll try.
Okay. Let me know if you have any kind of problem in this.
So the second one is propanoic acid.
Is it propanoic acid? How many carbon can you look at in the second one?
1, 2, 3, 3, 4.
3. 4 carbon, no? For
Yeah.
4 carbon,
So
what is the name?
pentanoic acid.
Pentanoic?
Butanoic. Yeah.
Butanoic acid. 1, 2,
Yeah.
3, 4. So it will be butane 1-oic acid, or you can directly write butanoic acid. There is only one carbon, so it will be methane 1-oic acid or methanoic acid. Now you can see 1, 2, 3, 4. Total
1,
carbon 4,
4.
so it will be butane.
Yeah. Butane,
1, 4,
butane,
dioic acid.
dioic acid, yeah.
This is your benzenoic acid. Yes or no?
Yes, sir.
Benzoic acid. Yeah. Or it's always basically benzene carboxylic acid. Benzene carboxylic acid. If you are unable to count this carbon, then it will be carboxylic acid. Like in case of aldehyde, when we were unable to count and we right? Can I change the slide for us?
Okay.
No. Now see, a structure of carboxyl group. The structure of carboxyl. This is the carboxyl group, you know that. It has 2 lone pair on this, and this is your carboxyl. Now you know that this is in conjugation, so there will be a resonance. So it will be O negative, and then there will be O. 2 lone pair is there, and there is hydrogen. And as you can see, since oxygen carbon give the electron to oxygen, so there will be positive charge. So again, this will be moving to this side, and then there will be negative charge on the oxygen, and there will be double bond between oxygen and hydrogen, oxygen and carbon. So this is the resonating structure of carboxyl group. Please do that.
Yes, I can.
Very good. Now see, we are going to do the preparation. Fawaz, are you done with this?
Yes, yes.
Very good. Methods of preparation, MOP of carboxylic acid. Methods of preparation of carboxylic acid. So the first method we are going to use is from primary alcohols and aldehydes. You know, primary alcohol, if you are going to use a very strong oxidizing agent, it will be directly converted into carboxylic acid. And if you are going to use a mild oxidizing agent on aldehyde, it will be converted into carboxylic acid. It's very easy. So if you have RCH2OH, that is alcohol, and you are going to use alkaline KMnO4, alkaline KMnO4, that is potassium permanganate, and after this you are going to do the hydrolysis, then it will be, you will be getting directly carboxylic acid. Whatever is the number of carbon, see, if this is propanol, then it will be converted into propanoic acid. If it is butanol, it will be converted into butanoic acid. This is the concept. Are you getting my point? There is another reagent that is used and known as, basically this is known as John's reagent, CH3 CH2 C double CH2 CH2 CH2OH. Now you can see that this is your butanol, right? This is your butanol, and if you are going to use this reagent CrO3 CH2SO4, this reagent is known as John's reagent. This reagent is known as John's reagent. So by using John's reagent on this primary alcohol, you will be getting directly the carboxylic acid. There is 4 carbon, so 3 carbon this, and this is your 4th carbon. Is that clear? Please do write it.
Yes, sir. Finish.
Now, if you are going to use some mild oxidizing agent, then it will be converted into carboxylic acid. Mild oxidizing agent on aldehyde. You have already read or studied this reaction in the previous classes. Can I change the slide? Fawaz, are you done up to this?
Yes, yes.
Now see, the second preparation is from alkyl benzenes. Alkyl benzene. It's very easy. Alkyl benzenes. So if you have alkyl benzenes, that means benzene is there, and also there is an alkyl group like CH3. And if you are going to use KMnO4, potassium permanganate, which is alkaline, that is KOH. KOH is basic alkaline, and then heat it. Then what will happen? This will be oxidized. That means basically hydrogen will be removed from there and oxygen will be added. That means this will be directly converted into carboxylic acid salt. And after this, if you are going to do the hydrolysis in the presence of H plus, so H plus will go and replace this K, and it will form C double OH. It's very easy. C double OH. I'm going to give you some question on this. Please do it. It is a very strong oxidizing agent. That's why it happens. CH2, CH2, CH3. And you are going to do this using the same KMnO4, KOH, and heat. Then let me know the problem.
So it's gonna be
See what
I
happens.
don't know the name, but it's gonna be like the
See.
benzene ring, and then okay, yeah.
See. This will be broken. First of all, not only this hydrogen will be oxidized. There is a reason. See this. Why this? So if you are going to break this bond and just remove all the hydrogen, there will be C double bond O, O minus K plus. That means OK. And since you are going to remove this hydrogen, because this is in conjugation and it can do resonance, that's why it is stable. If you are going to add this hydrogen, remove that hydrogen that I just ticked on, that means CH2 and CH2, and then it is C double bond O and OK. There will be no resonance. Yes or no? There will be no resonance with this ring because there is no conjugation. That's why always remove the hydrogen from the one which is directly connected to the benzene ring and then do the hydrolysis. Are you getting my point? After doing the hydrolysis in the presence of acid, you will get C double OH, carboxylic acid. Is that clear? Benzoic acid or benzene carboxylic acid. Nafisa,
Yes, sir.
can I change the slide? Please do write it first and then let me know. Let me know when you're done with this.
Yes, sir. Finish.
Very good. Now the next preparation is basically from is nitriles and ester. From the third one is from nitriles, that means cyanides, from nitriles and esters. Now, as you can see, it's very easy. Please do write with me. Nitriles are hydrolyzed to amides. They are converted into amides and then to acids in the presence of either acid or base as catalyst. Okay, so as you can see, I'm going to write the reaction. This is your RC triple bond N, nitriles or cyanide, and you are going to react this acid or base, which will act as catalyst. Hydrolysis will take place. So this will be directly converted. This will be directly converted into amide. This will be directly converted into amide. That means NH2. And after forming NH2, you are going to again do the same. Only the difference is H plus OH minus reacting, and you are going to heat it. Then carboxylic acid will form. How carboxylic acid will form? This bond will be broken. As you can see, this will have negative, this will have positive. So this negative will attach with this carbon. So as you can see, this will be converting directly into carboxylic acid. So this is how we prepare carboxylic acid from nitriles. So please do write it. Don't write ester here. From nitriles and amides. And as you can see, amide, first nitrile is converted into an amide and amide is converted into carboxylic acid. So if there will be any question to convert amides into carboxylic acid, you just need to write from here. So I'm going to take an example. This is your amide. This is your amide. And if you need to convert this in carboxylic acid, what you need to do? React with acid or base and heat it. And you are going to heat it. Then what will happen? This bond will be broken and this will be directly converted into carboxylic acid, CH3 double OH. And see, what will be the byproduct? The byproduct will be NH3. The byproduct will be NH3 because you know that this will be negative, this will be positive. So negative will go to positive and positive will go to negative. So byproduct will be NH3. Please do write. Then I will give you a question. Please do let me know when you're done.
Yes, sir. Finish.
Very good. Now, I'm going to give you tomorrow. Almost this chapter will be completed. So please do this. CuNH2. You are going to do this in the presence of SH3O positive heat. Please do let me know the name of the product. Okay, if there will be an extra class on coming Friday, will you be able to take it? 23rd December.
Yes, sir. Yeah. 23rd. We have vacation, so yeah.
Okay, very good. What about you, Fawaz? Will you be able to take it or not? Okay, thank you. So please do write it. This will be directly converted into, as you know, this will be directly converted into C double
Yes, sir.
OH, and NH3 will be the Okay, let's just start with another preparation. That is the fourth preparation from Grignard reagent. From Grignard reagent. So see, I'm going to write a point about it, and then we are going to write it. Write with me. Grignard reagents. React with carbon dioxide, solid carbon dioxide, that is known as dry ice, to form salts of carboxylic acid, which in turn gave corresponding carboxylic acid. Corresponding carboxylic acid. Corresponding carboxylic acids. After acidification, with mineral acid. So first write it, then I'm going to write the reaction and then explain you. It's very easy. Are you done with this?
Yes, sir.
See how the reaction will take place. RMGX. First, I'm going to write the reaction, then I'll explain the mechanism. It will be very easy. CO2. That means this is your OO, and in the middle it is C. So you are going to do the reaction in the presence of dry ether, since it is dupregnant, very reactive. So what will happen? It will be basically C double bond O, and then R will be there, and then O negative plus X. After this, you are going to do the hydrolysis in the same way that we did in aldehyde and ketones in this chapter. So it has two parts, H plus and OH minus. So you know that this will move to this. So what you will get RC double bond O, and with O minus you are getting H. So it will be carboxylic acid, and your byproduct will be basically that you don't need to write always. It will be OH and X. See how the reaction took place. It's very easy. This is your RMGX. So it will have positive, and this will have negative, and this will be your C double bond O and double bond O. So you always know that this is negative. That means basically it will take carbon's electron and there will be positive. So this will attack on the negative part. So as you can see, this is as it is C double bond O, and C is connecting with this R. So I'm going to write it R here. And you can see O negative is there. O negative is there. That will be attacked by this Mg plus X. Mg plus and X is there. So this and this are same. Only the direction is changed. And then are you getting my point? H2 has two parts. Have you understand? Have you got it, or should I explain it again? Please do let me know. Nafisa and
Sir,
Fawaz.
can you explain again?
Yeah. Yeah. First write it and then I will explain. Okay. First write the reaction, then I will explain. It's very easy. And
Yes,
there was
sir.
pause,
Okay.
pause. Maybe that's right.
Yes, sir. Done.
Fawaz, are you done with this? Now see. Concentrate here. Yeah. This is your RMGX. This is your RMGX, and this is your C double bond O and double bond. Now, as you know that this will have positive and this will have negative side, right? And this will have positive and this will have negative side. Yes or no? This carbon will take,
Yes.
this oxygen will take carbon's electron. So now it becomes C double bond O. And since this oxygen took electron from carbon, so can I write O negative?
Yes, sir.
So is this clear up to this? Nafisa?
Yes, sir.
Okay, now you can see this has negative, that means Mg plus will go to this. So Mg plus and Mg plus with Mg plus there was X. And after this, you can see this negative will go to carbon positive, so it will be R. And after this, you know that H2O, that means it has two parts, H plus and OH minus. So this H plus will go with oxygen and OH minus with magnesium. So this will what you get. Got it?
Yes, sir. Yeah.
So please do write it and let me know. I'll see you tomorrow and we'll complete this chapter, inshallah.